Okay, so let's evaluate this integral. So it says to find the volume bounded by the solid S as bounded by the paraboloid x squared plus y squared plus z equals 9 and the plane z equals 0. Okay. So if it helps to sketch the the surface out, then I would. I mean, you should. So I'll do it here too. So of course z equals 0 is the plane right here. So everything above the xy plane. Okay. Now how about this? It's a parabola it gives you, so that's really helpful already. It does open down, it's open up. Okay, so the only possibility that can be is if it opens downward like that, and then if you can visualize it, so here's the plane and then it opens downward. Z equals 0 and then it's downward, okay? Or it opens up and then the z equals 0 just like caps it. Okay, for this one, we can tell that if x is 0 and y is 0, then z is equal to 9. So it probably opens downward, right? Because they cannot open upward because it's not bound. There's no region that's bounded by the paraboloid and the plane, right? So if z equals 9 is up here, and then the projection, so it would be radius of 3. So something like this. Okay, and then this opens downward, so something like that. Okay, very bad drawing, but here's a paraboloid looking thing. Okay, so just the volume of this thing that's above the z equals 0 plane. Okay, so how do we set this integral? Well, we can write this as z equal to 9 minus x squared minus y squared. Okay. So obviously your z bound is going to be from the plane z equals 0, that's the least, all the way up to the top of this paraboloid, which is z equals to 9 minus x squared minus y squared. Okay. Now, is there an easier way to do this? Yes, there is. We could do cylindrical coordinates. Okay. So this would be equal to 9 minus r squared. Okay. Or it's polar coordinates. I don't remember right now. It's pretty much the same. Polar coordinates is xy, cylindrical coordinates is xyz. So this we could change z to 9 minus r squared. Okay. So if we write our triple integral out, it'll be from 0 to what we said over here, 9 minus r squared. Okay. And then we're just finding the volume, so it'll be z dr d theta. And remember, you need your extra factor of r outside, and you'll learn this when you learn changed variables. Okay, it'll be extra factor. So how about our r and theta bounds? Well, our r is up to radius of 3. So r is in the middle, so 0 to 3. And then for theta, we go all the way around, so it'll be from 0 to 2 pi. Okay, so when we integrate the first one, okay, we will be left with, so there's no z here, so when we integrate, we put a z, and then we plug in 9 minus r squared, so it'll be 9r minus r cubed. Okay. And then what's left? Dr z theta. Okay. If you remember your properties, you can break this up into the 2 pi of d theta times integral 0 to 3 of 9r minus r cubed dr. Okay? And this integral is simply just 2 pi. Okay? This integral we need to do the power rule. So 9/2 r squared minus 1/4 r to the 4th, valued from 0 to 3. Okay? Now we do the fundamental theorem of calculus. So this bottom bound will just make it 0. So 2 pi times, so this is 9, so 81 over 2 minus 3 cubed is 81, so 81 over 4. Okay. And then if you want to simplify, this would be 81 over 2. No, 81 over 4 is equal to 81 pi over 2. That's your answer.